In this video, we're going to continue looking at basic differentiation rules, and we are going to look at the power rule. This is probably a derivative rule that we will become most familiar with. If we are to find the derivative of f of x equals x, then that's the equation of a line, right? So if I were to draw this line, f of x equals x, it's the equation of a line. Its slope is 1, and its slope is 1 everywhere, and so the instantaneous rate of slope everywhere is 1. So our derivative is the instantaneous rate of change. It's the slope of a tangent line. That slope is 1. We could also roll through our limit definition. Right, so we could say the limit as delta x approaches 0, x plus delta x minus x over delta x. And when we do this, we get the limit as delta x approaches 0 of delta x over delta x. And since we have no delta x's there, we have a limit of 1. What if our function is x squared? If our function is x squared, if we were to roll through this and take our limit, our derivative using the limit definition, we would have x plus delta x squared minus x squared all over delta x. If you FOIL out the top, we will have x squared plus 2x delta x plus delta x squared minus x squared all over delta x. And on top, our x squareds will cancel. We'll be able to factor out a delta x from everything else. So we have 2x plus delta x over delta x. Our delta x's cancel, and if we do direct substitution, we get just 2x. So our derivative there is 2x. If we were to find our derivative of x cubed, f prime of x, we can go through that limit definition. That limit definition would be a limit as delta x approaches 0, x plus delta x cubed minus x cubed all over delta x. We would expand this stuff right here, and when we go through that expansion and do some cancellation, factor out a delta x, we would ultimately end up with 3x squared. So that derivative is 3x squared. So do we notice a pattern here, right? So here, if we look at these derivatives, the derivative of x was just 1. The derivative of x squared is 2. The derivative of x cubed is 3x squared. So you might say, oh, that power, it is showing up here. Right, this would be a power of 1, which shows up here. All right, so that power appears to be showing up. And so it does look like maybe the derivative with respect to x of x to, let's say, the n power. So that value of n, that power is coming down. What's happening to the powers of x here? So we don't see an x right there. Even though we don't see it, I mean, it doesn't mean that it doesn't exist there, right? So we could say that that's really an x to the 0 power, right? And so we have one x to the 0 power. We have a 2x to the first power and then a 3x to the second power. So those powers of x, those are simply going down by 1, right? So first power went down to a 0 power. A second power went down to a first power. A third power went down to a second power. Right? And so that is our power rule. If n is a real number, then the function f of x equals x to the n. That is differentiable, and its derivative is n times x to the n minus 1. Right? So if we were to take the derivative of x to the 8th, that value, that power of 8, we will pull down, we bring down in front, and then we subtract 1 from the power. This would be exactly identical to what you would get if you went through the whole limit definition of our derivative. If we take the derivative of x to the pi, the power is pi, we bring that power down, we subtract 1 from the power, and we would leave it like that. There's not much else we can do there. If we have 1 over x squared, that x squared being in the bottom, we don't have a derivative rule for 1 over x squared. But what we can do is we can use algebra rules and say, oh, we could rewrite that as x to the negative 2 power. Now it does look like x raised to a power. And so when we take our derivative, we can bring that power down, bring negative 2 down. And then we are going to subtract 1 from the power. Right? So it's negative 2. X to the negative 3. A negative third power is the same as a third power in the denominator. We also have something like this where we have a square root of x. Again, we can use our algebra rules, rules of exponents, and say, how do we rewrite a square root as an exponent, as a power? Well, that is x to the 1/2 power. And so we haven't taken a derivative yet. That's just rewriting it. And so now when we take our derivative, what do? We take the power, we bring it down in front, and then we subtract 1 from the power. And we could write this as 1 over 2x to the 1/2, because that x to the 1/2 has a negative power, and we could rewrite that still as 2 square root of x. That is our derivative. All right, in our next video, we'll take a look at more differentiation rules. We'll see you then.